Hi everybody, Kevin Reynolds here, Solutions Architect with Vology, and I'm standing here with Nick Dube, a technologist at HP, and we're looking at the new Apollo Supercomputer. And so HP has actually announced some of the most exciting new technologies in a long time, and so Nick's going to tell us a little bit about it.
All right, well, thanks Kevin for coming over. So first I'm gonna start with a little demo for you that we've been running here at the show to explain the concept of liquid cooling coming to a broader market. Like I like to say, liquid cooling is not the revolution in itself. It was there like in the 70s and the 80s. But the revolution is how do we make liquid cooling become a mass market product? So we've been using a bunch of very interesting technologies, and one of them is what we call a heat pipe. So this is a standard copper rod, basically 12-inch long, quarter inch big. Copper is used as one of the best heat conductors. That's why the greatest chefs use copper pans for cooking.
Sure.
And here you have a special device. So what I'm going to have you do is basically take one in each hand, right? Hold it like that. Drop it in the glass of cold water. Tell me which one comes up colder.
This one's cold already.
Already, right? Within seconds. While this one, you could be in there for like 30 minutes and it would barely start to get. There you go. So a heat pipe is basically a device that has a hollow core and that works as a phase change system. So basically, what we use here on the Apollo compute tray are a set of heat pipes where the tiny amount of water vapor that's in the heat pipe will evaporate as it captures the heat from the processor, travels as water vapor to the thermal contact plate here, and as the heat gets extracted, it goes back into liquid form and travels back. So vapor, liquid, vapor, liquid. It's a passive device. There's no pump. It doesn't break. Super efficient, and actually with a cost structure that allows us to basically give you that wide scale and give you the experience of an air-cooled server, but with the performance and the thermal performance of a liquid cooler.
That's outstanding. Now why air-cooled versus water-cooled? Or why water-cooled versus air-cooled?
So there's mainly three aspects. The first one is energy efficiency. With a water-cooled server, basically you're able to supply an Apollo system with 80 to 85 F water year-round, meaning that you don't need chillers. If you're saving chillers in your data centers, you're looking at saving
a lot of energy.
That system can run in most geographies solely on dry coolers or evaporative towers. NREL, or prototype system that was done in Colorado, they have no chiller at all in their 10 megawatt data center. It's purely evaporative towers. So that's advantage number one. Advantage number two is that because you're running the system with warm water, it actually comes with hot water coming out of it. Then you can do heat reuse. So NREL is basically using their 12-rack system as a furnace in the wintertime. So they're heating their 10,000 square foot office space and 40,000 square foot of labs with the computer.
Okay.
And they don't need any other furnace.
That's outstanding too.
Last but not least is better component thermals. So a liquid cooled server will allow you to go support the top bins for CPUs. Think a higher north of 125 watts, so 135 watt, 145 watt CPU, and keep the thermals more constant. No more hot spots, no more air starving for servers, no more fans running like crazy. Liquid cooling really brings you more performance at the silicon level as well.
That's awesome.
Okay.
So let's take a look at this map.
All right, so how do we do it, right? So the main thing is really to have a servicing model that's quite unique. So as you come in, basically you see that we have a vertical channel here that will have a whole bunch of those units that we call thermal bus bars. So the thermal bus bar is a unit that will come and make contact with the tray, and for all practical purposes, the compute tray always stays dry. The water flows through that unit here that always stays within the rack. So let's do servicing of a node. Basically all you do is first disengage the cooling system. As you do that, the thermal bus bar moves in, then disengage the electronics, pull the tray out, boom, you're done. You didn't break any water connection, there's no leak. You re-engage, put it in, electronics back in, engage the thermal bus bar, you're done. Servicing a liquid cool node as easy as servicing an air cooled one.
This is some really amazing technology, and Nick, I can't tell you how much we really appreciate your time and telling us all about this thing. These are some really exciting things.
All right, thank you very much.